So, hello, good morning. I think have a happy day. We have been considering the topics of emotion, and now we are in physics, and we want to explain details about motion, and we want to finish everything on motion. Now, to start all over, and this is like the class one on motion in physics. I've explained the importance of motion, but let me still summarize it that you see in physics, the one of the central of physics, which is in science, it was the sources that we have on motion, whereby motion can be generated without the human effort. And you realize that motion, anyway, when it comes to this issue of motion, it started from early days of life. From agriculture, you want to move, you want to plow the ground, you are using animals and not man. You are using water currents, you are using solar and many other source of energy. You want to generate motion from all this. So on motion, let's talk about the types of motion. In the types of motion, categorically, it is five. Some places you will be hearing nine, there and that, but centrally, we have five types of motion. The first one is translational motion. The translational motion, or you call it linear motion or rectilinear motion. Either way you call it, translational, linear, and this is the first aspect in short which we are going to heavily deal on. First of all on this class. Then secondly is the random motion. Then we also have oscillatory or periodic motion. Then we have rotational or circular motion, and we have the revolutionary motion. Now let me explain. Translational motion is like moving from one point to the other in a straight line. We are moving from one point to the other, from point A to point B, point A to point B. Translates. You're translating to translation, or you call it linear, or you call it linear motion. In short, when you come to physics aspect of optics, we'll be talking about rectilinear propagation of light, telling us that light travels on a straight line. Then the second is random motion. Now the random motion is an haphazard motion. Call it haphazard. If you are doing biology, you are hearing a Brownian motion. In short, some places they will still call it Brownian instead of random. You say Brownian motion. That is just like the movement of polygrins. When you look at microscope to look at polygrins that is moving in the water, you pour some particles. You see the way they move haphazardly. So that random motion they call it haphazard. Another one they call it haphazard motion. Haphazard motion. Then we have and this is the only aspect that it is beyond the scope of this class in terms of the calculation. Higher physics, advanced level physics and co. Then we have the oscillatory or periodic motion. This is the movement to and fro, and all these have their calculations we are going to do. Then we have rotational or circular motion. Now rotational and circular rotational or circular motion, you can compare it to revolutionary. Now rotational or circular motion, you are moving around, but you are not in a fixed position. You are moving around, but you are not fixed. That is rotational or circular. And a good example is like this is the earth, this is the sun. You can remember that the earth rotate around its axis. Excuse me. The earth rotates around its own axis to cause day and night. Remember, like this part now is the sun, all this part now is day, all this part is night. And the earth again will rotate again around its axis. Circular motion. You are moving around but in a fixed position. Now, when we have revolutionary is that you are moving around but you are not in a fixed position. You are not fixed, you are moving. Now, a good example was like a question that was asked of a car. You know, the tire of a car fixed to the car. When the car is suspended, the tire is moving around but in a fixed position. Now, when the tire comes down and the car is moving, in short, that was the question. They said the tire of a car that is moving in a car, that is on motion, which type of motion? Now, really, there are two types. The first one is the circular or rotational motion, and the translational. At the same time, it's moving from one place to the other. So, but when you talk about revolutional, you know, the earth moves around, causes seasons, 365 days for a year. So that is revolutional and rotational. Now, this is the basic type of motion that we are dealing with. But most importantly, the first thing, because all this motion will be dealt with, will be given the calculations, we're talking about questions and the rest. But the first one is the translational motion, which we want to deal with now. Translational motion. Now, as I told you before, that in translational motion is moving from one point to the other. Now, for translational motion, it has its motion. There are three, because we want to derive the formulas. The derivation of the formula of equation of motion. So we want to derive the equation of motion. Now, in the derivation of this equation of motion, I want you to understand it this way. You can move along the x-axis, you can move along the y-axis, and you can move along the one you can say the z-axis, which is really the projectile. I'm going to talk about projectile. We are moving along the x-axis from one point on the horizontal axis. You're just moving along the horizontal, a car moving from one point to the other along the horizontal axis. There are three formulas to that. Then you are moving along the y-axis, that is, you are throwing an object vertically upward and it comes down. It's going perpendicular. So this one also have its own three formulas. Then on projectile, that now you are now moving at an angle of theta. Now, take note, for the y-axis, you are also moving at an angle, but you are moving perpendicular, which is like 90 degrees. And because of that, we say the perpendicular. It does not really reflect in our calculation. But in projectile, you are moving at an angle. So you see, when you are moving in projectile, now another thing I want you to see, when you are moving along the x-axis, in short, when you draw your graph, you know, this is x, this is y-axis. When you are moving along the x-axis, what is the distance of y-axis? Y will be 0. And when you are moving along the y-axis, what is the distance of x? X will be what? 0. But when you are moving along a projectile, you are moving at this point now, you know, you are moving along x-axis, and you are, because at this value you have an x and you have a y. So you are moving, this is like, this is B, this is A. So you are moving along x-axis and along y-axis. So that is when you talk about this motion. So please, I want to come again. In motion or translational motion, it can be of three types. One, it can be along the x-axis, a car moving from one point to the other on an horizontal axis. Two, it could be along the y-axis, where you throw an object vertically upward, it comes down. It's still translational. And three, it can be along the x-axis, when you throw like a bullet. You fire a bullet, the bullet will go in a parabolic, in a projectile. It's not going directly vertical, it's not going directly horizontal, but it's going at an angle in such a way that it's going both y-axis and it's also going the x-axis. So we are going to derive the three formula here. We are going to derive the three formula. We are going to derive the three formulas for this translational motion. And that is why, please, if you know this translational motion, You see, the reason for the derivation of these formulas is for you to know how simple it is to derive it, one, and secondly, to be able to use it. You see, one of the things with physics is this, is that any formula that you are using, try to know the derivation. Because sometimes question does not even come on the end point, which is the formula. Is coming on the process. During the process whereby you are deriving a formula, sometimes question comes in between. So that is why it is not knowing. I know I can produce the formula, but can you use it? And not only can you use it, as before the formula, what do you understand the process, so that question can come in between. So that is why you try as much as possible to know derivation of formulas in physics. It will help you, and you know that is why secondly your mathematics have to be solid. You know, those of you going to physics, please, you must know strong in mathematics, strong in further maths, or you call it additional mathematics. You have to be very strong in it. It will help you to know better, and it will even, that is even what gives you the foundation in physics. Even in chemistry, you need to know them. So now, let's go to the derivation of the formula. Now, the formula for along the x-axis, you know the general three formulas that they use in the derivation. I want to write it. You have the first one, v is u plus at. You have the second one, s is ut plus half at squared. And you have the third one, v squared is u squared plus 2as. Now, before this, look at some of the parameters that you need to, and I think all this is not really a new thing, it's something you should have known. When you hear v, v means the final velocity. When you hear u, u is the initial velocity. A is acceleration, and t is the time taken. And the other thing you need to know here is s. S is the distance covered. So these are just the definition of some of these parameters. Although while we are going in the course of the study, I will still be explaining something. But another thing I want to steal from these three formula, please, I want you to know. In the first one, v is u plus at, there is one of the parameters that is not there, and that is distance. S is not here. If you look at this second again, if you look at the parameter, there is one of the parameters that is not here, and that is v, the final velocity. Then if you look at the third one, there is something that is not found here, and that is t, the time taken. So bear in mind of that. Now, let's talk about the first. How do we derive this first equation? This first equation is derived from the definition of acceleration. From definition of acceleration. That is where it's being derived from the definition of acceleration. And what is the definition of acceleration? Acceleration is defined as change in velocity all over time. What is acceleration? How are you accelerating? Like a car now. A car is stationary. You put on the key, you put on the engine, and you put on the jar, you move. You will see that the speedometer, it will move from 0 meter per second going to 10 meter per second, 30 meter per second. So you see, you are changing velocity with time. You are changing velocity with time. That is acceleration. As you change your velocity with time. Now, what is the change in velocity? You see, that's why I say you should know. There was a question like that. By the time we come to series of questions that combine all the types of motion, although it might be sectionalized, maybe for translational motion. The question, after saying a lot of things, the car started from 10 meters per second to 50 meters per second with time this and so. They said, what is the change in velocity? That was the question. So there are some of the parameters you may not even need for that. What is the change? The change is only the change in velocity. And what is that change in velocity? Now, what is the change in velocity? You started with an initial, you ended with a final. The change is the final minus what? Initial. all over time. So like in that question, what is the change? It's just like 50 minus 10, which is about 40 meters per second. That's just your answer. So that's why it asks you that when you have to know derivation so that in between question can be asked. So now, if you cross multiply now, you now have 80 is v minus u. If you rearrange, it is v is equal to u plus 80. So this is the first equation of motion. First equation of motion, change in velocity per unit time. That is the first equation of motion, change in velocity per unit time. Now the second equation of motion is derived, from distance is equals to the average speed times time. You know distance is speed times time. So they say distance is equal to average speed times time. So what is distance? Distance is decoded with s. What is the average speed? You started with an initial velocity u, final velocity v. What is the average? Average of two things. It will be v plus u divided by 2 multiplied by your time. Now, this is the point now. Now, if you look at this, v plus u, this is where it connects the second equation and the third equation. Look at the second equation now. In this second equation, what is the parameter that is not here? V. V is not here. So what do? Come to first equation. What is the value of V here? V is u plus 80. So you substitute V, which is equal to u plus 80, into this, into equation, okay, let me put here, into equation, let me put equation 4, into equation 4. So if you put that value now, you will now be seeing that S is what? V plus, U plus 80, you know this V now, which is this, plus U over 2 multiplied by T. So when you do that, what is the next thing now? You now have your, I'm just trying to differentiate all these things. So you now have your S is equals to 2U plus 80 divided by 2 multiplied by T. You understand? V is U plus 80 plus this U over 2 multiplied by T. So U plus U is 2U plus 80. Then when you use T to multiply, you have your S is what? 2ut plus 80 squared divided by 2, which is 2ut divided by 2 plus 80 squared divided by 2. You cancel, so you have your S is what? Ut plus half 80 squared. You see that? So that is that. So please look at this. This place is central. This place is central for equation 2 and 3. So for equation 2, distance is average speed times time, which is what we all know. It's not a big distance, speed times time. Distance, speed times time, you know that. But the speed now is because you are using different speed. You have an initial, you have a final. You may even have fourth speed. You have one speed, another speed, another speed. What you use is the average speed. So you use the average speed times time. So what is the average speed? You have your initial and your final. So it is V plus U divided by 2. That's average in mathematics. Multiplied by T. So you now let's say the second equation, there is no V. So you look at it, there is a V. And from your first equation, which you have derived from change of velocity by time, V is U plus 80. Then you substitute it here and you solve, you get here. Now what is the third equation of motion? The third equation of motion, I think I can use this place. So let me use some. Now for the third equation of motion, look at it. You are still working from here. Distance is average speed times time. You have it. But in this third equation, there is no T. So you come here again and you say T. How do we make T the subject of formula from here? How do we make T the subject of formula from here? So from here, you know that from V is U plus 80, your T will be V minus U over A. If you make t the subject of formula from here, you see that I say your mathematics have to be very solid. Just how do you make the subject of formula is a mathematics. So you make t the subject of formula, then you substitute it here. Since s is v plus u over 2 times t, and there is no t in this one, then you look at how do I remove this t? So when you substitute it here, you know how s is u plus v over 2 multiplied by v minus u over a. So you have your s is, now if you multiply these two, this is this is in factorization, in expansion. When you say difference of two squares, when you multiply this, you now have v squared plus u squared all over 2a. If you cross multiply, 2as is v squared plus u squared. So by the time you now rearrange, you now have your v squared is u squared plus 2as. So you now have your v squared is u squared plus 2a. So the point I'm trying to say is this, is that from this equation 3, v is u, average speed times time, distance is average speed. That's where it ties equation 2 and it's equation 3. So please, these are the two things you need to know, and this is all about the movement along the x-axis. Now we are going to talk about movement along the y-axis and movement along the